Okay, well, after a lot of procrastinating, I think this is not the. This apparently seems to work, but I think I know how to change this. I don't really want this. If this is using a square root, go on. Not that the speed matters. It's just I don't know. I just want to see if I can do it, without having to resort to fancy functions. So if I press the space, no message came up. It's always to do with the last line. Now it said that the last two lines intersected. Nothing. Intersect. It seems to be working, but a lot of times it seemed like it was working, and in fact it wasn't. But it seems like I can get very, one pixel off. I should use my. Here's the thing that makes it a more difficult problem than I originally thought. What was the last one? This? I guess so. I realize it's not quite as simple as what I was thinking. Computing the intersection. The question is, how do you compute the intersection point? Here's if this is the equation for a line. Well, I don't have it written down. The equation for a line, as you know, I'm getting faster at typing this in. Okay, I just cut myself off there. Probably just a moment too soon, but in order to play catch up, I drew this picture. I cut myself off because, as per usual, here I was watching a replay. I didn't upload it as a WMV. I wasn't sure. And there I was explaining to myself all of the answers I couldn't figure out for myself. Oops, this should really be 2 minus 1, but whatever. Change notation. I'll change it. You know what? Just a second here. I've written this so many times. I should just have a copy of it handy. Usually I use 0. And then it's not 0, it has to be the other one, or else it doesn't work out from 0 to 1. Whoops. Yeah, now I am wasting your time. Sorry about that. But in this case, I want 1, 2, 1. Hey, oh, I got that backwards. Semicolon underscore. The last one. No, well, we're both of them backwards. Just one. Oh yeah. Very important, sir. You see, what I was about to explain incorrectly, as usual, was that in the parametric world, right? Uh, how do you solve for t? All you have is one equation, right? And two unknowns. That is, there's not really one t, there's two t's, right? If these lines intersect somewhere, this one will have one t value, and this one will have another t value, and so they're not the same. And I think I even started saying that. It's so bad. And the other thing, as I was describing this, I think I said this uses square root, and I want to figure out how to do it without having to use fancy functions, right? When only two tutorials ago, I sat here and I told you that these two differences, right, are the same differences that the numbers that come out are the same numbers that would appear in this equation. Oh no, just A. Right? AX? When was that? I don't know, C1? Did I get it right on top? Wow. No, I can fix that problem. Oh dear. Yes, I can fix that. Right? I said that those A's are the same as those differences. And you know how to solve these sorts of things, right? You use determinants and stuff. You would, like, this would be, x1, a1, ax by minus by ax, and so on. And then that way you would invert a 2 by 2 matrix and get a solution in x and y. And that would tell you the intersection point of two lines. These define two lines, right? That's what that guy's doing. He's converting it to XY format, so he can solve it as a system of two linear equations. Now, what I did was kind of wacky, and now I think I want to keep it because it's kind of cool. But my method of solution. Here's my method. I imagine that it doesn't have to be this scenario, but in my mind, I was imagining the reason the idea came up in the first place. I was imagining the scenario where it had just failed on me. I had two lines, still in line mode. I don't know what color I'm using. White. And it was like this, and then the other one was like that or something, right? And I thought, well, if I'm this line, what I'm going to do is I'm going to do a switcheroo, because I only got one equation and I got two unknowns, right? This t and this t, like this x and this y. But there aren't one. It isn't one equation. It's two equations. Here are the equations. I'll write it down as one equation. P1 plus Now, it's too bad we have to call it T. I mean, I could use tau plus tau P2 1 whoops, equals, now I'm going to stop that at this point here. That's part of it. And now I'm, oh dear. Get out of line mode. Okay, now the other half is going to look like this. So I'm going to change colors. Before I do that, or I'll do part of it and make sure I change. It's a trick I've learned. P3 is that you just do a bit. That way when you hit enter and you've done the whole thing in the wrong color, it won't feel so bad, or it won't hurt you as badly. Okay, now I know I'm in the right color, and I'm safe. Plus, now I don't want to call that T. I could call it T, but it looks too much like tau. What's another thing that looks time like? Phi, theta, theta, theta. P4 minus P3. Okay, and I was saying that's one equation and two unknowns, but it's not one equation and two unknowns. It's two equations, right? There's the what they call the x component. What is that? I forgot to correct it again. Something wrong with my brain. I mean, I've repeated the same mistake. There's the x component of the equation and the y component of the equation. But I thought I couldn't solve it that way, and I hadn't realized because it's been so long since I've been doing this stuff. What I did instead was I was thinking about recent comments, and I thought what I'm going to do is I'm going to invent a new coordinate system such that my line represents one of the axes, right? Like we'll call it the u-axis. So if I was the purple guys, I would call this the u-axis. So that means P1, P4, P3, P4 is in the direction of the u-axis, and then there's a perpendicular axis this way. So this is like the y-axis kind of, and then I would compute a perpendicular and create another axis, as I've done here, called the v-axis. Now if I go into line mode, and I'm in the right color, just do that, and do, oh dear. Wonderful. Oh my god. What was the last one? The last line drawn. Oh, that was it. Darn it. Okay, well, it looks perpendicular. So this would be the v-axis. Okay? And the great thing about that now is that this is like y and this is like x, right? But really, if this thing was right near the new x-axis, right? Then all I got to do is wait till the y component of the equation becomes 0, right? All I got to do is find this, y. Wait for y to become 0, and then it would be crossing the x-axis, and then I could solve for t there, and that, no, I have to wait for it to cross this axis, wait for if this had to be the x-axis, and when I just have to wait for it to hit the x-intercept, and that's my line, right? And that might be over here, or in the middle. Clever trick, I thought. And the way to do the conversion was I create unit vectors, one this way and one this way, and just dot product the x and y components with the new unit vectors, and that's what these dot products are for. It's hard to tell from the equation. Here. Perp, right? I'm imagining that perpendicular is the new x-axis, and I just solve for it, crossing the y-axis. Because if perpendicular is x, then I'm taking on the role of being the y-axis. So as soon as it crosses the y-axis, I know when it would have intersected with my line, and that actually works. You saw. Did you see a demonstration? But see, another way to do it is to convert it into xy's and then solve a one of those linear equations. And a line. Oh, I don't want that one. Is it on? Seems to be working. And it's very accurate, like to within pixels. See? And that's where the trouble would happen, would be I would get an intersection, but they didn't really intersect. It's just that it was between 0 and 1 when it crossed the new y-axis, which is exactly aligned with the line, my line, if I'm one of the lines. So then I have this test now. If it's between 0 and 1, t, me, them, they are the first line. I am the second line. This normal vector, parallel, is a vector in the direction of my P2 minus P1, right? And perpendicular is just perpendicular. And so I'm taking it that t equals 0, I guess, is, I don't know, not the origin? It doesn't matter what t equals 0, is it? positionally, it's going to cross. If I imagine the y-axis as being along the vector or my line, then solving for it crossing the y-axis, that is just x equals 0, works. But I have to make sure to put it at the right offset in the at the beginning for t equals 0, that it's nothing's changed, that the distances are the same, and so there's a small adjustment, which I think is correct. I don't even know for sure, but I think, well, let's see, it's still running. No, how about like near this end? Got that. Oh, it's that one, isn't it? Yeah, I thought I just turned. Oh, no, I don't want that one. Oh dear. I forgot to press this too. Okay, it's clear. How about this side? I can get pretty close. How about this side? But how about if I just touch it? Oh, it didn't catch that one. It should have. So maybe it's not perfect. See, that should have been a hit. Although it's pretty iffy. I mean, we're talking about pixels. Just gotta make sure that it's as good on either side, and it seems to be. So I don't think I'm off in the adjustment part. But you see that. So I understand completely now why that his formula looks the way it does. It's because he's done the right thing. Realize that it's easier to solve it in x's and y's than in t, right? Where you've got to do rotation of axes and make a new coordinate system, and just solve the two simultaneous linear equations you do in linear algebra. If you don't know about that'll come up on the math tutorials on my other channel. The idea of solving two simultaneous linear equations in 2 dimensions is exactly the same idea as finding the intersection of two lines. In 3 dimensions, it depends on how many equations you have. If you have 2 equations and the 3 unknowns, then the solution is a line. If you have 1 equation, then the solution is a plane. If you have 3 equations, then the solution is a point. If there is a solution, and that would be the point where 3 planes intersect. You try to imagine that in your head. Okay, I'll stop this. It's fluid on the end of the other. And now that I've been able, I can do intersecting lines, at least with this formula. I might keep it here just because it's a different way, and it's a good double check against one method against another. Now I can do the polynomial. The polygon with the funny corners, right? And I'm 100% certain I understand now why that that idea is absolutely correct. The counting of the odds and evens filled. Okay, it makes perfect sense. I explained this in the other video, and it was a good explanation, so I'll put it back. Whatever direction you start out going, maybe you don't know at first. One side is considered in, and another side is considered out. All right? Now that fact never changes. And it can never change at any point during your journey around the object, unless the object itself is invalid. I'll show you an example. I can do it quite easily. I just need a triangle, like that maybe. Oh, and that thing with the triangle, that was completely my fault. I mean the polygons. I could have picked those things up. I was trying to drag them instead of just clicking. You see, it's possible that the side could switch if you continued and this was a straight line like that. But this is invalid because this is not. If this is solid, then you wouldn't be able to pass through like that, right? So this is not solid, and that's not a valid solid object by definition. So therefore, the inside is always to your left or your right. And so, hence, if I move to the outside, towards the outside direction, I'm immediately outside. And the only way to get back inside would be to cross a boundary. Boundaries don't go from outside to outside or from inside to inside. They toggle. So therefore, if to go from here to here crosses one boundary, then that's inside. Outside, inside. Outside, inside. And here, where the inside is to my right, I start out inside and then outside, inside. It's even numbers before you're inside again. And what about here? Is it possible here to get messed up? No. If something really is outside and you're looking at it from the point of view of here, then it's one crossing from inside to outside, and it's outside. From here, it's no crossings, and so you're going from outside to outside, and it's all fine and perfect. Okay, see you.